let's say that they ask us to draw a 70-degree angle. So to draw an angle that's positive, what we do is we start here and we open counterclockwise about 70 degrees. And then what you do is you go like that, and then you draw the original side. And so this pink angle here, that would represent our 70-degree angle, where this and this, these have names. This one is called the initial side, right? This is the initial side. And this up here where it finishes, that's what we call the terminal side. See that? So that's for a positive angle. So that was for 70. Let's do a different one. What if they ask us to draw something like, let's say 275 degrees, okay? Well, we know some common locations. Like for instance, this is 0, this is 90, this is 270 here, and JK, this is like 180, right? And this is 270. So if they want you to go 275, then you know that in blue, you have to go more than that, more than that. So that's 270, but go a little bit more change. You see that? And that's about 275. And then in a different color, I draw the terminal side. Let's try that again. I draw the terminal side. And pretty much the blue spiral, you can point at it and be like, okay, teacher, that is my 275-degree angle. So that's for positive angles. What if on the test or on a quiz, whatever, what if they ask you to draw an angle? Let's say that's like negative 100 degrees, okay? So for negative, what you do, instead of going counterclockwise, instead of like that, what you do is you go down clockwise, okay? So go in that motion about 100 degrees. So can we agree that so far that's like 90? So to reach 100, just do like 10 more and stop it there and just draw your terminal side. And you can say, okay, that spiral or that arc, that, teacher, is my negative 100-degree arc. So that's how you draw angles. Now, another really common thing in trig is degrees, and check it out, degrees and radians. You see, if I ask you to draw a 45-degree angle, right? If I say, hey, draw just any angle that looks to be about 45 degrees, what you would do is you just draw like a 45-degree angle, right? But what if I ask you to draw an angle that's like 7 pi over 5 radians? I would sort of freeze up because I don't know what that means, right? So the idea is we have different ways of measuring angles. We have degrees, but we also have radians. So now let me show you how to convert. See, this is something that you really want to jot down. So we can title this Converting Between Forms, okay? Converting between forms. So let's say you want to go from degrees into the world of radians. Here is what you do. What you're going to do is you're going to multiply. You're going to multiply by pi over 180, okay? If you want to go from degrees to radians. Now, what about vice versa? How would I convert from radians back into the more familiar world of degrees? In that situation, you would multiply by 180 over pi. Right? That's what we would do. We would multiply by 180 over pi. So jot that down. And so let me erase this. And you can pause the video if I'm going too fast. So you will see on your quiz or on your midterm, they ask you to convert. So let's say I gave you something like, let's say 150 degrees. But we want radians, okay? We want radians. So take 150 and multiply it by the conversion factor, which we just established as pi over 180. So we need to multiply these two objects. So what I can do is I can drop a 1 underneath the 150. And then on a calculator here in purple, on a calculator, I would type that in. I would literally type in 150 over 180 on a calculator. And it would reduce it And it would say something like 5/6, it looks like. And then all you have to do is attach the pi, and then you're done, right? So that maybe I'll just write the word radians. I'll write the word radians in here. So as it turns out, 150 degrees is the same thing as 5 pi/6 radians, right? It's a completely different system of measurement. Let's try one like kind of backwards. Let's say I give you something like that says 7 pi/3 radians. Let's actually make this negative. And on the midterm, they're like, okay, turn this into degrees because we're more familiar with degrees. So if I'm given something in radians, you copy it down and we multiply by 180/pi. Let's clean this up, and whatever this is, that'll be our answer in degrees. So how would I, do all that there? Well, maybe we can see that this pi can knock out with this pi. So there's just like a 1 left in the bottom. And then I would reach for my calculator, right? Just grab your calculator and just type that in. Type in -7 times 180/3 times 1. And it should give you, well, let's see, if we try to do this by hand, the 3 would turn the 180 into 60. And then 60 times 7 would be 420, but with a negative, and attach the degree symbol, right? So that's how you go from radians back into degrees. And that's pretty much what we did like the first part of our first class meeting. And then after that, I'm looking at my notes here. After that, what we discussed with the class was arc length. So now we can get into arc length. Okay? And here's the idea. Let's say that I have a circle. Let's say this is the center, and let's suppose that this is the radius. And let's say that I draw another radius. So I have a radius and a radius. And let's say that I have an angle here in the middle. And this is called a central angle because it's in the center or in the middle of the circle. And the idea is this. If I were to use, let's say, a green highlighter, if I were to go from here along the edge, you see that? Along the edge, along the border of the circle. That is a piece of string that I've sort of laid out on the edge. I want to know how long is that piece of string that's on the edge of the circle. It's like the crust of a pizza, right? I want to know the length, like how many inches, how many feet, how many miles. There's a formula that we use. And the formula goes like this, watch. In the textbook, they go S equals R theta, where S is the length of the arc, okay? That's what S is, the length of the arc. R is the radius of the circle. And theta is your central angle, but it must be in radians, okay? So let's do some examples where I give you a picture and then you have to give me the arc length of the arc that's given using this cute little formula, okay? So let's wipe this clean. So let's say I have a circle and let's say I have the center. Let's go like that. Let's go like this here. Let's say this is 5 pi/6. Let's say the radius is like 8. And your goal is to go from this red all the way to this right here. And we'll call this S. So your goal on the midterm would be like, okay, find the length of this arc. So we know the formula. S equals R theta. S is the goal, so it stays S. Now, R is the radius, which is given to be 8. And then theta is our central angle, which is in radians, which is necessary. So we get something like this here. And then what you can do is maybe just type in, like on a calculator, just type in the green. Only the green, right? Just type in the green, and your devices will say something like 20/3. And then you can just copy down the pi and attach it. And let's say that the 8 was actually 8 inches, then your answer would be inches, because this represents the length of the piece of string. I'll draw it here in green. You see this green piece of string? The length of that would be whatever this is right here, whatever this is as a decimal. But we prefer that our students leave the answer like that instead of some weird decimal. Just leave your answer like this. It looks better. All right. And then one more thing for the first day is sector area. So let me wipe this clear here. So another concept kind of related to that one was areas of sectors. Okay. Areas of sectors. So here's the idea. If I have a circle and if I have a radius and then another radius, you see this stuff in there, that's a sector. It's like a slice of pizza, right? And I want to know the area, like how much space there is inside. So what you need is you need to know the radius, and then you need to know this green central angle, which we'll call theta. And the formula goes like this. Area equals 1/2 r squared theta. And again, we remind our students that our angle theta, it must be in radians, right? The angle, it's got to be in radians. And r is the radius, theta is the central angle, and the area is usually the goal. So let's do an example like that. So let's say you have a circle like this here. Let's go there, let's go like this, and let's go like that. And let's say that from here to here, let's say that this is, how about 5 pi over 3, 5 pi over 3. Let's suppose that the radius is like a 6, and the goal is all of this red. You want all of that area. That's what you want. All right. So our formula, 1/2 r squared theta. That's always the formula. And by the way, you don't have to memorize these. I'll give students a cheat sheet, like a little index card, and you can put whatever you want. You can put all your formulas and stuff. I'm not a fan of memorization because you still have to know what you're doing anyways, even if I give you the formulas, right? So let's see. So 1/2 is 1/2. R is the radius, which was given to be 6 squared. And then theta is the central angle, which is 5 pi over 3. And I know I say it a lot, but I'll say it again. I would just type in this here in blue into a calculator, and then you can just attach the pi at the back. So on a calculator, that would be like, let's see, that's 36. It looks like that would be 30. And then you can just attach the pi. Okay? And let's say this was actually 6 inches, then the answer would be that many square inches, because this is an area. An area is 2-dimensional, so that's why it's square inches. In the previous problem, it was just inches because it was like a piece of string which has 1 dimension. Okay. And that was the whole first class meeting. And then now, if we can switch gears here to the second class meeting, I don't think this will take as long. This will take a little bit less time. So wherever we are in the video, we're like more than halfway, I'd say. So now for the second meeting, this is what we did. So let's say that we have a triangle, a right triangle. And we have words like hypotenuse, we have opposite, and we have adjacent. So our students we want our students to know which of these 3 words goes on which of these 3 sides. So here's what I always recommend. Across the 90 degrees is going to be the hypotenuse. So I know that this is always going to be my hypotenuse, the one that's sort of at a slant. Okay. And then the remaining sides, what I do is I go to the angle theta and I shoot down the middle, and the opposite side would literally be called the opposite side. And the remaining side would be the adjacent. So whenever I do my labels, I always first label the hypotenuse, and then I label the opposite, and then I label the adjacent. So for instance, let's say you have this picture here, and let's say that you're theta there. Label the 3 sides. So my hypotenuse would be this one. Down the middle from me, theta, that'd be the opposite. And then process of elimination would be the adjacent, right? So we got to know how to do labels. Another thing, we must be comfortable with the Pythagorean Theorem. Let's say you have a right triangle. Let's say that's a 5, and let's say that's a 12. And you have got to find the third missing piece. We know the very famous Pythagorean Theorem, this guy here. Now, A and B are the legs. So you can call this A, you can call this B, or you can switch those. It doesn't matter. But for sure, the hypotenuse will be called C. So let's take the 5 and the 12 and drop them in for A and B in any order. It doesn't matter which one you call which. But you definitely want to use parentheses, okay? Go calculator on that, and that'll be 169 equals c squared. And then you can square root, and you'd get c equals 13. And so the missing length would have a length of 13, right? The missing side would be 13. This can get tricky, so let's not think this is all that easy. Watch. Here's one that can stump some students. Watch this one. Let's say this is 3 square root 2, and let's say this is square root of 5. And your goal is to find the missing leg called b. So let's go Pythagorean theorem. So we know that it's a squared plus b squared equals c squared. We know that this is going to be c, and if this leg is b, we'll call this one a. So watch me take an L. Watch what I write down, and then I want you to see how that what I've written is an L. Okay, watch. This is me taking L's here on YouTube. And ask yourself, or let me ask you, what's wrong here, right? What did I forget to do? So what you really, really want to do is you don't want to forget these blue parentheses. You have got to have those. Because look, before, over here, without the parentheses, I would only be squaring the square root 2. But the square also applies to the 3, which is why you want to put parentheses, especially on your calculators. So you got to have those parentheses, right? Without it, we're taking L's, and we're not about that. So let's see. So this is 5 plus b squared. On a calc, this would be 9 times 2, which is 18. Take away 5 from 18 and square root. The missing leg would be the square root of 13, it looks like. Yeah, so the missing leg would be about square root 13. So we know how to label opposite, adjacent, hypotenuse. We know how to find missing legs. Now we can piece these things together. But before that, you have got to remember your 6 trig functions. So if you already know sine, cosine, and tangent, you can just fast forward through this part. But if not, I'll just write down all 6 trig functions. Okay, so we have sine, cosine, tangent, so katoa. And then on this side, on this column, we have their respective reciprocals. And this is a very traditional representation, sine, cosine, tangent, and in order, cosecant, secant, and cotangent. And what these guys are, what they do is they compare 2 sides of a right triangle. That's all that these guys are. They're just comparisons of objects. So let's do an example here. Let's say you have a problem where you have something like this, okay? Let's say they give you something like this on the test. Let's say 1, let's make that a 4, and let's make this, let's say, a 9. And your goal is to find, let's say, the secant. Your goal is to find secant of theta, right? You got a picture, and your goal is to find secant. And so, how does this work? What do I do? Well, first of all, why don't I make the goal secant and tangent? Make it a little bit more interesting. So first of all, I probably can't do much if there's a missing piece, right? So let's find the missing piece with Pythagorean theorem. So we know it's going to be 4 squared plus b squared equals 9 squared. So 16 plus b squared is 81. So b squared equals... what's 81 minus 16? What is that like? Is that 65? Looks like. And then square root, square root. So the missing leg is about square root 65, right? Square root 65. And now I have my triangle, and I got all the sides, but they're not labeled. So give them names. We know this is the hypotenuse. Across from theta is the opposite. And this would be the adjacent. And I'll give them what they want. They want secant. Well, you know that secant is, what was the definition of secant? Hypotenuse over adjacent. And so based on our picture, my hypotenuse is 9 and my adjacent is 4. So that takes care of secant. But they also want a tangent. And tangent is opposite over adjacent. And that would give us, let's see, that would give us square root 65 over the adjacent, which was 4. Done, 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 done. Finished. You see that? So usually they'll give you a picture, and then you just label Pythagorean theorem, and then just give them what they want. So maybe we can do one more, and then I'll feel comfortable just like stopping it there. So I'm looking at my notes here. How about something like this? This is a good one to finish up with. So watch, let me clear this. And this problem here, this last one, this will really put everything together. So why don't we let cosecant of theta equal 3? And the goal is this. The goal is to find tangent squared of 90 minus theta. So this last problem, this is going to take a little while. So let's see how this goes. I'm given a fact and I'm given a goal. I like making pictures. I think the pictures help, right? The last couple of problems, they had pictures. So here, I want to draw a right triangle. Now, I don't know, they don't exactly tell me where or how to draw my right triangle. So whenever you can draw it however you want, I like to just go like this, watch. To me, this is like a standard position looking right triangle. But it's empty, and I have no numbers, and I can't just make up the numbers. That's not fair. So here's what you do. You see where it says cosecant? Put a 1 below the 3. And look at your definition of cosecant. Cosecant is what over what? Cosecant is hypotenuse over opposite. So the 3 in the numerator, that's your hypotenuse. And the 1, that'd be your opposite. And make your labels on your triangle. You know this is the hypotenuse. You know this is the opposite. You know this is the adjacent. And we have 2 of the 3 sides. The hypotenuse is 3. The opposite is 1. Pythagorean theorem would say square root of 8. By the way, you don't have to simplify square root 8. I know you can simplify it. You don't have to just leave it like that. My picture's done. Now I move on to the goal. The goal can be rewritten like this. You could look at this as tangent of 90 minus theta in brackets, and then the power of 2. See the exponent there? I like to put it on the outside. It just looks easier to look at. Now, pencils down. In case you're writing this, go pencils down, just watch. Let me just teach you a little math for a second here. If I have a right triangle, I know that I need 180 degrees. I know that. And I know that this guy, that's 90 degrees already. It's like halfway there. So I know that between this red and this red, these two add up together to give me 90 more. So let's say that this was 1 degree. Can we agree that that would be 89? Because it has to add up to 90. Let's say this was 2. You'd say, duh, this is 88. Okay, stay with me here. Let's say this was 3. You'd say 87. We get the point. But watch. Instead of 87, I'm going to write it like this, watch. Instead of 87, I am going to write 87, but in a different way. In a way that goes to show you that whatever this is, this one would be 90 minus that. So for instance, if I were to call this, let's say Q, let's pretend that's a Q, right? That's a Q. This angle would be called 90 minus Q. If this was, let's say, I don't know, H or something like that, then this would be called 90 minus H. So now go back to your problem over here on this side. If this is theta, what could this be called? Well, based on that same logic, we could call it 90 minus theta. And that's what I'm trying to get at. Look, this would be called 90 minus theta. And now that's what we need over here, because in this part right here, they're telling us to go and position ourselves there. So now for this problem, we are not going to stand there. No, 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 no. We are going to position ourselves at 90 minus theta, which is right here. So now, if we're the little stick figure person, I'll draw a little stick person. If that's where we are, then these labels might change. For instance, over here, that would no longer be the adjacent. That would be the opposite. And here, that would no longer be the opposite. That would now suddenly be called the adjacent, because we switched positions. Because instead of theta, they said 90 minus theta, which is the other little corner. The 3 is still 3. So now, do the inside of the brackets. How much is tangent of 90 minus theta? Well, 90 minus theta means go stand there. And from this position, tangent is opposite over adjacent. So that would be square root 8 over adjacent, which is 1. And then all you have to do is square this number on a calculator, and you get back a final answer of 8. So for a problem like this, you have a statement which leads to a picture. Go Pythagorean theorem, make your labels. But if it's 90 minus theta, then instead of your original position, you're going to be on the other little corner pocket, right? So you relabel things, and then you just give them what they want. So hopefully that helped. If you have more questions, please let me know, and I'll gladly drop another tutorial.